All right, good morning, 6th grade. This is Module 3, Lesson 15, Locating Ordered Pairs on the Coordinate Plane. I did start with writing some of this out because I needed both hands for this. So on your sheet, they'll just give you this 1 point here. The point below represents 0 on a number line. Draw a number line to the right starting at 0, then follow the directions of the teacher. So the directions are you're going to draw an x-axis. The x-axis is this horizontal line going through the 0 line, the 0 point, sorry. And then you're going to draw a y-axis, and the y-axis is the vertical line that goes through. So basically, you're drawing two number lines that intersect at this point, that meet at this point, okay? And just like number lines that we did before, the numbers to the right of the 0 are positive on an x-axis. The numbers to the left of the 0 are negative. The numbers above the 0 are positive for a y-axis, and the numbers below it are negative. This point in the center with the coordinate 0, 0, because it's 0 units on the x-axis and 0 units on the y, is called the point of origin, okay? Which leads us into example 2. Example 2 asks, all points on the coordinate plane are described with reference to the origin, okay? Basically, they're giving you points away from this point here, okay? So what is the origin and what are its coordinates? The origin is where the x-axis and the y-axis intersect or meet, and they meet right here. The coordinates are 0, 0, okay? To describe locations of points in the coordinate plane, we use ordered pairs of numbers, okay? That's what we talked about yesterday, ordered pairs. Ordered pairs are basically a set of coordinates, kind of like this, 0, 0, okay? Order is important. So on the coordinate plane, we use the form. Sorry, I'm looking up here. We use the form x, y, okay? We name the x coordinate first and then the y. The first coordinate represents the point's location from 0 on the x-axis, so on that horizontal line. And the second coordinate represents the point's location from 0 on the y-axis, the vertical line. Okay, so we go on the horizontal line first, whether it's left or right, depending on if it's positive or negative. And then we use the y to go up or down after. All right, let's take a look at exercise 1. Use the coordinate plane below, right here actually, to answer A through C. Graph at least 5 points on the x-axis and label their coordinates. Okay, so just on the x-axis, okay, which means we just want x-axis coordinates. So just plotting along this horizontal line, and any 5 points will do, okay? So we'll plot, oh, and it says label their coordinates on the coordinate plane, okay? So you have to label them. So on the x-axis, I'll label, let's see, this one, 2, 3, 4, and one more, 5. All right, and now I have to label them. So when they don't go up or down, the y coordinate is automatically 0. But now we have to check how many over we went for the x. So I'm going to start with this one all the way over here. So that's -1, 2, 3, 4. So this one is -4, 0. This one here is -1, 0. This one here is 2, 0. 3, 4, 5, 0. 6, 7, 8, 0. All right. For B, it says, what do the coordinates of your points have in common? Well, the 0, right? They're all a point. All of them have a y coordinate of 0, okay? All have a y coordinate 0. What must be true about any point that lies on the x-axis? Well, if it lies on this x-axis, okay, so if any point lies on this x-axis, the y-coordinate must be 0 because the point is located 0 units above or below above or below the x-axis. So if the point is right on this line, then the y-coordinate must be 0 because it is 0 units above or below. So because of that, all points that lie on the x-axis So all points on the x-axis have a 0 y-coordinate. Because, I'll abbreviate, it is 0 units above or below. All right. Now we're going to use the same coordinate plane for number 2. Now it says graph at least 5 points on the y-axis and label their coordinates. So now we're using this vertical line because that is the y-axis. In case you need to remind yourself, I like to do it if it's not already labeled. This is the y-axis and the horizontal line is the x. Okay, so y. So now we're going to go ahead and plot points along this line here, and any 5 points will do. So I'll go up here so it's easier to to label them because obviously my x will get in the way otherwise. So here's 1, 2, 3, and let's do a few down here. 4 and 5. Okay, starting with my topmost here. So for my x, I'm not going to the left or right any units at all. So I know for sure my first will always be 0 for all of these. All right, so we have 1, 2, 3, 4, whoops, what, lost my count, 1, 2, 3, 4, 5, 6, 7, 8, 9. So this top one is 0, 9. 1, 2, 3, 4. I'm sorry, guys. Hold on 1 second. Sorry about the interruption about out there. So we have 0, 9 up here. Now I count for the others. So here's 1, 2, 3 for this one. 4, 5, 6 for this one. Okay. When I go below this line, it becomes negative. So we have 1, 2, 3, negative 4, negative 5, negative 6, negative 7. Okay, so now it was true for the x-axis that the y-coordinate will always be 0. Look what happens to the x-coordinate if they're along the y. Okay? All right. So what do the coordinates for your points have in common? They all have a 0 x-coordinate. So what must be true if they're all on the y-axis? The x-coordinate will always be 0 because they will not be any units to the left or right of the y-axis. Okay? So sorry. So x-coordinate will always be 0 because it is 0 units to the left/right of y-axis. If the origin, so let's look at number 3. If the origin is the only point with 0 for both coordinates, what must be true about the origin then? Okay, so remember that the origin is always 0, 0, right? So what must be true of the origin? The origin is the only point that is on both the x and the y-axis. That's the only thing that's true about the origin. The origin is the only one that is always on both axes. So if you notice that, it's on the y as well as the x. The origin is the only point that is on both axes. Okay. Now let's look at example 3 here. Quadrants of the coordinate plane. So a quadrant, the x and y axis divide the coordinate plane into 4 regions called quadrants. Okay, why are they called quadrants? The word quad, right here, means 4. Okay, so there are 4 quadrants on a coordinate plane. The y-axis crossing with the x-axis will create these 4 quadrants. Okay, that's why they're called quadrants. It's because they're split into 4 sections. Which of the 4 regions did you work on most in grade 5 and why? You mostly worked on this quadrant here back in 5th grade. Okay, because you guys weren't introduced to negative numbers so much until this year. Okay, so the top right coordinate plane right here is what you guys mostly worked with last year. We only used this region because we had not learned about negative numbers yet. Now that we know about them, now we're going to be working with all 4 quadrants. Okay. All right. So they are actually named very specifically with Roman numerals. If you guys forgot what Roman numerals are, I'll remind you. Roman numerals are, they look kind of like an I, okay? But they signify a number. This one would be 1, 2, 3. This is 4. And this is 5. We are only going to concern ourselves with 4 because we have 4 quadrants, okay? And they each have a very specific number. The upper right quadrant, this one here, is called quadrant 1. Okay, and then the remaining are numbered moving in a counterclockwise from quadrant 1. Okay, so counterclockwise, remember that a clock goes this way. So if it's counterclockwise, we're going the opposite way. So this is quadrant 1. This is quadrant 2, quadrant 3, and quadrant 4. Okay, I know it's a little bit wonky that they go this way, but that's the way they're numbered, okay? Okay, we extended axis X in example 1, and we revealed that we got another quadrant in our coordinate plane, okay? So when we extend the y-axis, we saw that we create these 4 quadrants. All right, so remember, quadrant 1 is the one that you guys first started with in 5th grade. And now, in 6th grade, we go through all 4 quadrants and we go counterclockwise. Okay, so 1, 2, 3, and 4. All right, let's take a look at number 4. Locate and label each point described by the ordered pair below and indicate which quadrant the points lie in. So now that we labeled them up here, we already know which quadrant is which. So looking at 7, 2, we move over 7 positive units and up 2. So 1, 2, 3, 4, 5, 6, 7. 1, 2. Here is 7, 2. What quadrant is that in, everybody? This is quadrant 1, according to what we labeled up here. Let's look at 3, negative 4. So we move over 3. 1, 2, 3. And we move down 4. 1, 2, 3, 4. So this is 3, negative 4. And what quadrant is that in? According to what we labeled up here, this is quadrant 4. All right, 1, negative 5. Here is move over 1. Negative 5 is down 5. 1, 2, 3, 4, 5. So here is 1, negative 5, and still in quadrant 4. Negative 3, 8. Moving to the left 3. 1, 2, 3. Positive 8 goes up 8. 1, 2, 3, 4, 5, 6, 7, 8. Sorry, I lost my breath there for a second. Negative 3, 8 is here, and this is quadrant 2. And finally, negative 2, negative 1. So we move to the left 2 and down 1. So here's negative 2, negative 1, and that is found in quadrant 3. All right, kiddos. So in closing, the x-axis and y-axis of the coordinate plane are number lines that intersect at 0 on each number line. The axis partition, that means split the coordinate plane into 4 quadrants, okay? And points in the coordinate plane lie either on an x-axis and one of the 4 quadrants. And remember that we number these 1, 2, 3, and 4. Okay? All right, guys. That's it for today. That's lesson 15. And some of you guys mentioned that you'd like a different outro, that you guys would like this little guy here to say bye to you. Bye! Bye! Say see you tomorrow. See you tomorrow. Oh. All right, guys. See you tomorrow. Bye.